Okay, here we have limiting reactant problem number 2. I used the photosynthesis equation. This one I just wanted to show that we don't always start with 100 grams of everything. Sometimes you start with different amounts. And again, we need to figure out which one is going to give us the least amount of glucose, because that's what the question's asking here. Which one's giving us the smallest amount of glucose? And that will be the one that is going to tell us what our limiting reactant is. So this question is not a how much of the excess do you have remaining. It's just a straightforward how much glucose will be produced if you've got 64 grams of water and 88 grams of carbon dioxide. So let's calculate our carbon dioxide first. We have carbon, which has a molar mass of 12.0107. And we have oxygen, which has a molar mass of 15.9994. We've looked that one up a bunch of times, and we've got two of those. So going to our calculator, 12.0107 12.0107 plus 15.9994 times 2 equals 44.0095 grams per mole. And that's our CO2. H2O. Once again, we have oxygen, 15.9994. We haven't looked up hydrogen yet today, so let's go look it up. 1.00784. And we have two of those. Go to the calculator. Times 2 plus 15.9994. We get 18.01508 grams per mole for water. Okay, so now what we need to do is figure out how many moles of each we have. So we're currently working on water on our calculator, so let's just go ahead and do that one. We have 64 grams. We are going to multiply by 1 mole for every 18.01508 grams. And we will find that we have 3.5525 moles of water. Now carbon dioxide, we have 88 grams. We're going to divide by 44.0095. And find that we have 1.9995 moles of carbon dioxide. So 88 times 1 mole over 44.0095, 1.9995 moles. Now, like I said in the last video, there are a bunch of different ways you can determine the limiting reactant. This one is pretty easy because our two reactants both have the same coefficient, which means that for every 1 mole of carbon dioxide that reacts, you have to have 1 mole of water to react with it. So we can simply compare these two numbers in this one, here and here, and say which one's smaller. Okay, so 1.9995 is smaller than 3.5525. So that means that when 1.9995 moles of carbon dioxide reacts, also 1.9995 moles of water will have reacted. So we're going to have extra water. We're going to have another, what is that, 1.5 moles of water, but we're going to be out of carbon dioxide, so the reaction is going to stop. So we are going to use this number here to calculate how many grams of glucose we have. So we have 1.9995 moles of CO2. And we are going to multiply that by our molar ratio, which is 6:1. So we will multiply by 1 mole of glucose over 6 moles of CO2. So 1.9995 divided by 6 equals 0.33326 moles of glucose. Now we need to find the molar mass of glucose, because the question originally asked for the answer in grams. So carbon, we've already looked it up, 12.0107 grams. We've got 6 of those. Hydrogen, 1.00784. We have 12 of those. And oxygen, 15.9994. We have 6 of those, and we had looked up all those numbers on this previous page. That's why I just wrote them down instead of going and looking them up again. So that will give us our molar mass of glucose, and then we can multiply by this number. So glucose, 12.0107 times 6. Plus 1.00784 times 12 plus 15.9994 times 6 equals 180.15468. Grams per mole. We have 0.33326 moles of glucose. We need to multiply it by its molar mass. And that will give us our final answer. Times 0.33326, 60.038 grams of glucose. If we go back to our problem, we were given 3 significant figures. So our final answer would be 60 grams of glucose.